Let's talk about balancing equations. Balancing equations is what a lot of people think of when they think of chemistry and problems that you would do in chemistry. Balancing equations is a really important function. So let's take a really simple one. We've got some hydrogen and some chlorine, and we're going to combine them to make hydrochloric acid or hydrogen chloride. If it's in a gas state, we call it hydrogen chloride. If it's dissolved in water, we would call it hydrochloric acid. The hydrogen here is diatomic because it runs around in pairs, so it's H2, not just H, and the chlorine is chlorine 2. We cannot change subscripts when we balance equations. So, for example, sometimes people will try to do this. They will put an H2Cl2 because they'll try to revise that to match what's on the other side. That is absolutely not something you can do. To balance an equation, we can only add coefficients. We cannot ever add subscripts to balance the equation. Now, later on in the semester, you will have to put in subscripts before you balance the equation because you're going to be predicting the products, and you have to make sure that they're the correct formula. But in order to balance the equation, all we do is coefficients. So if we have two hydrogens on the left, we need two hydrogens on the right, and since the only place we can put a number is in front, the coefficient, we'll put a 2 there. That happens to take care of the chlorine as well. We have two chlorines here, and this will also give us two chlorines, so that one was super easy. Let's do a little bit more interesting one now. Let's take aluminum nitrate, and we're going to add it to some lithium carbonate, and that will form lithium nitrate and aluminum carbonate. And the aluminum carbonate will precipitate out of the solution. If we've got this dissolved, we will see two clear liquids going together, and we're going to end up with precipitate falling out of the solution. So we now are going to look at this equation and say, how can I balance it? Of course, I can only add coefficients. I can't change any of the subscripts. The subscripts are what they are because of the nature of the compounds. Aluminum nitrate has one aluminum ion and 3 nitrate ions, and that's the way it is, and we can't change that. But we can add coefficients to figure out the ratios. So let's look at the aluminum first. On the left, we have 1 aluminum, and on the right, we have 2 aluminums. So we're going to fix that by putting a 2 in front of the aluminum. Now, of course, that 2 in front here also applies to the nitrate. And the nitrate already has 3 nitrates in the formula, and then we have 2 formulas worth, so that's 6 nitrates. So we have 6 nitrates on this side. On this side, we only have 1 nitrate, so we're going to have to fix that. So let's put a big 6 in front of lithium nitrate. Now I have 6 nitrates and 6 nitrates. I have 2 aluminums, 6 nitrates, 6 nitrates. Aluminums and nitrates are just peachy. What about the lithiums? Here I have 6 lithiums because of the 6 in front. That gives me 6 lithiums as well as 6 nitrates. Here I have 2 lithiums. So 2 lithiums will not equal 6 lithiums. So I'm going to have to get 3 times as many on the left, so I put a big 3 in front. And 3 times 2 is now 6 lithiums. So my lithiums are all good. The only thing we haven't talked about is the carbonates. So 3 carbonates. So I have 3 carbonates on this side. And oh my goodness, look on this side. I have 3 carbonates. If we do this correctly, if we do this balancing business correctly, we should come to a point where, oh my goodness, it all just falls into place. You notice that I didn't go to the individual atom here. I didn't say nitrogen atoms and oxygen atoms. Sometimes you have to do that. But if the polyatomic ions stay together from left to right and they don't rearrange themselves into new configurations, then you can just go ahead and balance nitrates together. If we had nitrate on the left side and nitrite on the right side, we would have to deal with nitrogens and oxygens separately. But as long as they stay together, we can just simplify matters. Let's do one more. Let's do a combustion reaction. So we're going to take butane, like is in a butane lighter, and we're going to burn it. We always want to burn things or blow things up when we're in chemistry anyway, so that's, I get regularly told that's why people take chemistry classes. I want to blow something up. So at least we're going to burn some butane here. So that's something, a little flame. We need to get carbons, hydrogens, and oxygens all separately now, because the oxygen on this side is, on the left here, is molecular oxygen, and it's in compounds on the right side. So we're going to have to balance everybody individually. I could start by looking at the carbons and say I have 4 carbons here and 1 carbon here, but I want to just compare my hydrogens too, especially in combustion reactions. I know I have 10 hydrogens here, and I'm going to have to, they're going to always be in pairs on the right side. I have 2 here, so I would have to take that times 5. Now look at that and say, if I put a 5 in front of my waters, what will that do? That will give me an odd number of oxygens. And on my left side, the oxygens are all in pairs. So there's no way I can deal with an odd number when everything comes in pairs. So I'm going to just start out by putting a 2 in front of my fuel, the butane. That way I have 20 hydrogens, and when I go to fix the hydrogens on the right, I put a 10 in front of there. I have 20 hydrogens now, 20 hydrogens, and I now have an even number of oxygens in both places. In the carbon dioxide, they're in pairs, and I have an even number in front of my waters, so that'll work out great. So let's go back and fix the carbons now. I have 8 carbons. I should put an 8 in front of this carbon dioxide so that I have 8 carbons on this side as well. Now let's count up oxygens. Oxygens here, 8 times 2 is 16 oxygens. 10 times 1 is 10 oxygens. So 16 plus 2 plus 10, 16 plus 10 is 26 oxygens on this side altogether. They come in pairs on the left, so that'll mean 13. So my balanced equation is 2 butane plus 13 oxygen makes 8 carbon dioxide and 10 water. Don't be afraid of large coefficients, especially when you're dealing with combustion reactions. They sometimes get large. What you don't want is don't want them to all be multiples of the same number. If these were all even numbers, 2, 13, 8, and 10 are not, but if I had all even numbers, I'd say, oh gee whiz, they all divide by 2, so we want the lowest whole number ratio that we can get. But 2, 13, 8, and 10 don't have any common factors other than 1, so I think we're good.